the basics. So first of all, what is a complex number? A complex number is an enlargement basically of the real numbers. The real numbers include all the numbers, positive, negative, 0, with all the variations of whole numbers, decimals. So let's say 2.45, that's a real number. The number 10 is a real number. -1 is a real number, and so forth. So it's basically all the numbers that we always use. So what is a complex number? Complex number says, okay, we know that in real numbers, there's no such thing as a square root of -1. Basically, there's no such thing as a square root of any number that's negative. So what the complex number says, okay, let's imagine that there is. So I stands for imagine. And let's call the square root of -1 I. What that enables us is to take every number that is a negative number and find the square root of that number. So let's say I want to find the square root of -16. Using the rules of indices, I know I can multiply -1 and 16 separately under the square root because -1 is 16. And therefore, I will call the first part I. The second part I'll calculate, which comes out 4. So the answer here will be 4i. And this is a complex number. Every complex number will be written in the form, we'll call it usually the last letters of the alphabet. So it'll be Z, W, U, and so forth. We won't call it X, Y usually. And it'll be in the form A plus BI, which means it'll have a real part plus an imaginary part. The imaginary part is counting how many i's we have. So let's look at a few examples. Let's say the number 2 plus 3i. 2 is the real part, and 3i is the imaginary part. What about 4 minus 3i? The first part is the real part, and the imaginary part. Doesn't have to be whole numbers. We can write 1.5 minus 3.75i, real and imaginary. Okay. What about the number 5i? So that's the imaginary part, and it looks as if it doesn't have a real part, but of course it does. It's just 0. So therefore, that's why we didn't write it. So you can write it or not write it. Depends what you want to do. What if you had the number just 10 and I don't see any I there? Well, that's just because it's 0 i's. So my real part is 10 and my imaginary part is 0 i's. So that's my imaginary part. Therefore, we can see that every number that's a real number, they're ordinary numbers that we always use, they're also complex numbers. But every complex number is not necessarily a real number because we are adding all the square roots of negative numbers. Okay, so what can we do with complex numbers? So we can do everything we can do with real numbers. We can add. How do we add? We add real to real and imaginary to imaginary. Okay, so let's see how we do that. So let's say my first number is 2 plus 3i, and maybe I want to add it to 5 plus 1i. I said we add real to real, so 2 plus 5 makes a 7. And I add imaginary to the imaginary, so 3i plus 1i makes 4i. Okay, what else can we do? We can take or subtract, and we do it in the same rule. Real minus rule, imaginary minus imaginary. Okay, so let's look at an example. 2 plus 3i minus 5 plus 1i. 2 take 5 is minus 3. 3i take 1i is 2i. So that's our answer. Let's look at another example. 2 plus 3i minus 5 minus 1i. Real minus real. 2 take 5 is minus 3. And 3i minus minus 1i. So remember, minus minus is a plus. So 3i plus 1i makes plus 4i. What if I need to add I plus 10 plus 3i? So again, real with real, so it's only 10. There's no other real number here. Plus I plus 3i, which makes plus 4i. What if they gave me a big line of things that I need to add? Let's say 10 plus 3i plus 4i minus 2i minus 10. Maybe we'll make minus 101 plus 1. And I need to calculate all this. So now we know to add and subtract. So all we have to do is take all the real parts and add them. So 10 minus 101 plus 1 So minus 101 plus 1 gives minus 100. 10 minus 100 gives minus 90. And then I look at all my imaginary parts and I add them or subtract them from each other. 3i plus 4i is 7i. 7i take 2i is plus 5i. Okay, so that's adding and subtracting. What happens if we have to multiply? So when we multiply, we just multiply the ordinary way we multiply. But what we have to pay here attention is when we get I squared, which we will many times. So I is minus 1. So I squared will be square root of minus 1 squared, which means just minus 1. Therefore, I squared is minus 1. And we have to pay attention to this information because in multiplication, many times we get this and we have to change the I squared to be a minus 1 because we have to add real to real, imaginary to imaginary after we do the multiplication. So let's look at a few examples. So maybe we have to do 2 multiplied by 3 plus 4i. So first with first, 2 times 3 is 6, and then 2 times 4i is plus 8i, because 2 times 4 is 8, so 8 i's we have. It's exactly, think about I like an x, so it's 2 times 4x, so it's 8x. Okay, let's look at a different example. What if we had minus 2 times 3 minus 4i? Okay, so minus 2 times 3 is minus 6, and minus 2 times minus 4i, minus makes a plus, 2 times 4 is an 8, so plus 8i. What if we had an I in front? So maybe I multiplied by 3 plus 4i. So I by 3 is just 3 i's, and I by 4i is 4i squared. And here comes the dealing with the I squared. We know that I squared is minus 1, so this part is minus 1. So 4 times minus 1 is actually minus 4. So when I finalize my answer, I'll be putting minus 4 plus 3i. That's because I put the real part in front usually, but you don't have to. You can also write 3i minus 4. Let's look at another example. What if we had 2 plus 2i multiplied by 3 plus 4i? Okay, so when we multiply two expressions, we just multiply first with first, first with second, second with first, and so forth. So 2 times 3 is 6. 2 times 4i is 8i. 2i times 3 is plus 6i. And 2i times 4i is plus 8i squared. Again, here we have our I squared. We have to treat him first. So I squared is minus 1. So 8 times minus 1 is minus 8. And now we have a sum here that's adding and subtracting. So you have to do real with real. So 6 take 8 is minus 2. And 8i plus 6i is just plus 14i. Let's look at another example. What if we had 2 minus 1i multiplied by 3 minus 4i? 2 times 3, 6. 2 times minus 4, minus 8i. Minus 1i by 3, minus 3i. And minus 1i by minus 4i. Minus by minus is plus. 1 by 4 is 4. I by I squared. Calculate the I squared. That's a minus 1. 4 times minus 1 is minus 4. And I now add real with real, imaginary with imaginary. So 6 minus 4 is 2. And minus 8i minus 3i, minus 8i minus 3i is minus 11i. These are multiplications and adding with subtracting.